from sugar to amount of sugar. Can you tell me that how is this? Can you tell me?
Sir, your voice is not clear.
My voice is clear. Is it better? No, Hmm. Is I'm audible to you?
Yes, sir.
Can you tell me that how to do this is water? This is water here and mixed together make the sugar. It is not chemically bonded. It is physically bonded. Physically bonded or physically bonded. But if I'm saying water, hydrogen, and oxygen, when react together, they form H2. This is this is chemically bonded. Chemically bonded. Can you tell me that how can you recognize whether something is chemically bonded or something is physically bonded? So in compounds, elements are chemically bonded, but in mixtures, substances are physically mixed. Can you tell anyone us? Everybody will be starting the camera first and keep it on. Camera. Aisha, are you there? So how can we recognize this that something is chemically bonded or something? This is very simple. Just because if I'm saying this is hydrogen react with oxygen, it's from H2O. In this water, hydrogen and oxygen are not showing very equal properties. And it is a fluid, it has been burning and then burning or combustion. But in water, it extinguished fire. Extinguish fire. It is not showing its property. Okay, so that's why we say
Sir,
that
can you hear me?
yes, I can hear you.
Sir, I have some connectivity issue.
For the last three classes, you are saying continuously. The last three classes, you are not allowing camera. So what I'm saying here is that water in water it is physically bonded because it is still showing its property. It does not become something new. Sugar, which has a taste of sweetening, when added to water, it is still showing the property. Moreover, it can be separated by simple physical method like evaporation. But in compounds, hydrogen and oxygen cannot be separated by boiling, evaporation, filtration, something like that. Are you getting my point? So,
Yes, sir.
the smallest particle of compound is a molecule. Smallest particle of a compound is called molecule. Like for example, H2O, CO2, and O2. These are all compounds. Smallest particle like hydrogen atoms. The two hydrogen atoms and one oxygen atom combined together, it is a molecule. Another same hydrogen atom. These are the molecules. Okay. There can be billions of molecules in just a very small drop of water. That is called molecule. Got it? Somewhere? Somewhere? You understood everyone?
Yes, sir.
So note it down. Compounds and two or more elements. I know we have spent some time at this in check the knowledge and everything. The term has to. Jan, when you notice, please let me know.
Done, sir.
Okay. So I have discussed questions in the previous class also. Okay, now in the we were discussing the true solutions and provides. One more thing I will just we will try to explain the elements. Elements क्या होते हैं? There are 140 elements per element. There are 140 elements per element.
So your voice is very low.
That's nice. Okay, okay. Is it clear? Then maybe some or is it just uh, okay, Tanisha, is it clear now because it has not check this improved. Okay, is it clear now? Or should I use the different microphone that is on my caller? Okay, let's try. Uh, is it clear now, Tanisha?
No,
Is it
sir.
clear?
Breaking in between.
Now, is it clear? Now,
Oh, your voice is breaking in the middle and your voice is very low.
is it clear now?
Yes, sir.
So when if it is still breaking, then breaking. Okay. So what I'm saying here is that it is 114 elements are present in nature. And elements are the substance that consist of only one kinds of atoms. Elements are the substance that consist of we will write a definition in proper instead of this one we'll write an element. An element is the substance that consists of only one kinds of atom, one kinds of and different element have different kinds of it. An element is a substance that consists of only one kind of atom. Different elements have different kinds of atoms. Okay. Got it? Some of that.
Yes, sir.
So that is very, very important. Because element is a substance that consists of only one kind of atom. Different elements have different kinds of atoms. For example, nitrogen is an element, but nitrogen oxide, nitrogen oxide is a compound. Is a compound. But nitrogen oxide is a compound. Nitrogen is an element, but nitrogen oxide is a compound. Yeah.
Yes, sir.
Um, have you noted we were discussing the types of solution in the previous class. So have you noted that what are colloid suspension? Check it in notebook, please. Check it in notebook, please. What are colloids? Suspension. Colloids suspension. Okay, along with we have two solutions. Two solutions. Do we have written that? Colloids and suspensions
No, sir.
comes under the heterogeneous mixtures. Mixtures. And two solution comes under homogeneous mixtures. The main difference between the colloids and the suspension is colloids, sorry, true solution. True solution, and I'm talking about the true solution. True solution. And like the example, sugar solution. Sugar solution. Salt solution. Yes. So if you have this water, just making it particles so that to represent this is water. Water plus water. Or we can have this. Okay, so we can, because it is transparent, totally transparent, so I'm not representing the color here. But if I'm taking the milk, the colloids, this is the milk, and it has so when you pass a beam of light through it, you pass a beam of light through it, you will notice that the path of light will be visible to you. Path of light will be visible. Got it? Or you can say that the particle will be visible to you. Particle will be visible to you. When you see in this one, path of light will be visible to you. And here the big particle will be visible with the polaritic solution. They will scatter. And here this is air because the air have dust, so here also the path of light because it is dust here. Okay, this is the milk particle. Sorry, dust particle. This is the dust particles. Dust particles. And this is the milk particles. Milk particles. But if I'm taking a torch here, and it will be visible to you outside of it, according to the dust. And here then. No path of light will be visible here. No path of light will be visible. So the path of light is visible. Path of light will be visible in colloidal solution. This is colloids, and this is true solution. Okay. So the path of light is visible in true solution. Sorry, in colloidal solution, because the particle is big enough that it can scatter the beam of light. Like for example, we have this particles. The size is big enough. So what would happen when the light ray fall over it? It is scatter and make it this particle to visible, because some of the light will enters in our eyes, some of the rays. Okay, we are standing here, and it will goes into our eyes. Okay, if I'm standing here, then again the light will fall over it. Okay, and it will scatter. So the particles will comes and hit, and some of the rays will be visible to our eyes. Okay, resulting that this particle will be visible. The particles is very small in size, but if the rays are moving and no particle is in the size of the particle is not big enough that it will scatter the beam of light, so the path will not be visible. They will keep on moving. Got it, Samajan? When a light, when the particle pass over a surface, sorry, over the light, or the part when the light rays falls on a particle which is big enough that it can scatter the beam of light, then it is considered to be as scattering of light. And this effect is called Tyndall effect. This effect is called Tyndall effect. Not only here you can see this one, you can also see this one uh, in the during the sunny day or the summer winter seasons, if the sunlight is coming from and entering to our room, okay, through the window, then we see dust particles. So these and they form a path that is called that is called Tyndall effect. That okay, Tyndall. Tyndall effect. So please note it down. It's in everything. Very important. When you're done, please let me know. Sure. You done? You done? Tanisha, are you there? Hello.
Yes, sir, done.
So please note down the distortions of true solution provides us experience. Assuming the particle size of the true solution is smaller than 10 raised to the power minus 9 meter, which is 1 nanometer, which is very, very small. And the size of the bolide lies from 10 raised to the power minus 9 to 10 raised to the power minus 6. And the suspension lies from like the soap solution, the particle is means its particle is visible with the naked eye. Like soap solution, okay, like muddy water, spot suspension. But in colloidal, the particle is not visible with our eyes. The particle cannot be seen with naked eyes. Here it can be seen. This property, this and this is same for the two subjects. They seem homogeneous. This seems to be homogeneous, but actually they are heterogeneous. Why they are heterogeneous? Because they show Tyndall effect. Heterogeneous mixture have to show their Tyndall effect. Particles do not settle down. Here it do not settle down. It is transparent. It is translucent. They don't show Tyndall effect. They show Tyndall effect. So please note it down.
Okay, sir.
When you're done, please write it fast. We write it fast. Done.
No, sir.
Done.
No, sir.
Don't write the 6 point. Okay.
Okay, sir. Done, sir.
Question number 3 continue. Or should we answer the question? Carbon, a mixture of sulfur and carbon disulfide. Carbon and sulfur and carbon dioxide. Is a heterogeneous mixture or a homogeneous mixture? Um, Note down the question. Notice 7. It is a heterogeneous mixture, but it will show tender effect. Okay. It is not a true solution. It is not liquids. So the generally true solution is formed by liquids. Okay. So it is a heterogeneous mixtures. Heterogeneous mixtures and don't show tender. These the following are homogeneous mixtures. So the following are homogeneous in nature. Faster.
T.
Homogeneous. Homogeneous means that has same proportions. Okay. So you're saying C, first and fourth. First and fourth. Air is not homogeneous. But we can say if air is not having any dust particle, because pure air is means only the gases, not the dust particle. Then it is homogeneous. So one and four is the correct answer. Got it?
Okay, okay, sir.
Okay, give some example of tender effect observed in our surroundings. Can you give any examples of tender effect observed in our surroundings? Like the lights coming out through the window during uh, in a dark room during the daytime. Got it? So the dust particles will scatter the beam of light and the path of light will be visible. Got it?
Headlight,
Yeah. Are you seeing something?
headlights in winter
Yeah,
when
yeah.
there is foggy.
Yeah, yeah. Very good, very good. It is called headlights also. Good. Now, can sea water be classified as homogeneous mixtures? Can sea water be classified as homogeneous mixtures? Yes, it can classify as no, no. Sorry, heterogeneous mixtures. Then, because yes, we can classify sea water as heterogeneous mixtures. Just because seawater does not only contain salt and water, it also contains impurities like sand, okay, sand particles, silica, and other calcium and magnesium particles. So that's why it is considered as heterogeneous mixtures. Okay, but it is not crystal white. It is crystal clear. Explain why the particles of porous solution do not settle down when left undisturbed. Because they are simply say that they are simply light enough that they do not settle down. Otherwise, means because of their zigzag motion, they keep on moving because they are light and weight. Okay, got it? Got it?
Yes, sir.
The next topic, I will start. I will start. I should start in the next class because this is really important. Okay. Now we will associate with the practice.
Thank you, sir.
Let's start actually responding questions we are into the topic. Okay. Okay. Hello. Excellent. कहाँ गई ये पता तो करो So Tanisha, where have you gone? Is I audible to you?
Yes, sir. Sir, I thought you said the class is over, so I left.
No. Oh no.
Sorry, sir.
So, next is this one. So let's start. Let's start writing the answer of the particular question. Back what is it? What's the answer for the question number three? Can you tell me? Answer for question number three. You are muted. You are muted.
C,
What's the answer for question number three?
C.
C. The nature of iodine is an antiseptic. This solution has property when we have to of iodine in potassium iodide. No. Iodine in the iodine what iodine mix. Iodine in iodine. Next one is this one. Chemical change, chemical change. Then this next. Write down question number 13 in my book, please. Question number 13.
Okay, sir.
When you done, please let me. I will take you to write the answer. Okay.
Okay, sir. Sir, done.
So write down the answers. Question number 13. Homogeneous field when it is only going to have water and salt in it. Okay. But heterogeneous when it contains salt, water, mud, decaying plants, and etc. Okay. When it is heterogeneous. Note it down, please.
Okay, sir. Done, sir.
Next. Explain why the particles of collider solution, question number 16. Explain why the particles of collider solution do not settle down when left undisturbed, while in case of suspension it do. Yes.
Done, sir.
What could be the answer? I don't have the question number 16. Particle size in suspension is larger than the collider size. Also, the molecular interaction of molecular interaction of suspension is not strong to keep the particle suspended.
Done, sir.
So your preferred response is that the particle in suspension is larger than those colliders of it. And also the molecular interaction of suspension is not strong to keep the particles suspended on for several longer. Okay, so you understood? You understood
Yes, sir.
the concept that why do they settle down? Why do because the interaction between the particles is very good in chloride, so they keep on uh, in, attracting them, more brittle. But in suspension, the particle is big enough that it does not, the interaction is not good. So that's why it's another reason that it's settling. Okay.
Okay, sir.
What are the favorite quantities given to the gold and allow or silver for the purpose of making? Yes, you know what? When two or more metals mix together, they form alloys. We call them alloys. Alloys are the mixtures of two or more metals or metals and non-metals like steel. Steel is an alloy of carbon and iron. Like brass. Brass is an alloy of copper and zinc. Similarly, there are different alloys that we use. For example, gold is mixed with 24 karat gold is mixed with uh, 24 karat gold is a pure gold. But if we mix some copper or silver to it in order to make it hard during the time of making ornaments. Okay, so we top it or we add some copper or silver to it to make the ornament. That make it hard. Okay, got it? समझ आया?
Yes, sir.
So can you tell me which of the following is element and compound in this? The following is element and compound in this.
Sand is compound.
Sand is compound. No, sand is a mixture. Sand does not have any formula. Copper. Cu is copper is an element or compound? Tell me. Cu, copper is an element or a compound?
Element.
Yes, it is. Sodium chloride
Element.
in no, it is aqueous. It is no, sodium chloride is compound, but it is in aqueous, so it is a solution. But it is asking only elements and compounds. Classify the following 2.2 elements and compounds and mixtures do not mean. Mixtures नहीं होता. So sand is not a compound. Okay, but it is saying any NaCl, so NaCl is a compound. Wood is not a compound. It is made up of carbon and hydrogen. F2 is a compound. Hg is compound. Oxygen is sorry. F2 is an element. Hg is an element. Zn is an element. O2 is an element. It is a compound. It is a compound. Keep in mind that diamond is also made up of pure carbon. Diamond is something that is made up of pure carbon, so that's why diamond is also an element. Got it? Got it?
Yes, sir. Yes, sir.
Okay, tell me that whether these are which of the followings are not compound. Are not compound. Which of the following are not compound?
Carbon.
Not compound. Yes, iron is not a compound. Chlorine gas. It is saying chlorine, but it is not saying chlorine is hydrogen chloride something. Gas is a state. So if it is raining chlorine gas, chlorine okay, so gas does not represent it as a compound. So find out the single word. If it is single word, then it is it is an element. Okay, but it should be if it is two words, it should be like gas, liquid, and something. That represents the state. Like potassium chloride is a two word. It is potassium and chloride. It is a compound. Iron is single, so it is an element. Iron sulfide is a compound. Aluminium single again single written, it is an element. Iodine, it is single written, it is an element. Carbon is an element, but carbon monoxide, two letter word, not a state. It is not monoxide means single oxide. It is a compound. Okay. Sulfur powder. So powder is a state. That is representing the physical. Sulfur powder is also an element. Got it? समझ आया? So
Okay,
लिखो
sir.
इसमें जिसमें जो जो एलिमेंट है जो कंपाउंड है फटाफट से लिखो.
Sir, should I write down this question?
Yeah, you have to write down and you have to mention that which is element in which is not.
Done, sir.
Okay. So you mentioned each and everything properly. Hmm?
Yes, sir.
Okay. So that's what we're going to do in this. So